cation is a positively charged ion and comes from a positive element. And an ion is a negatively charged ion and comes from a negative element. What does nomenclature mean? A nomenclature is assigning a name to each particular part of the science. What is a binary compound? A binary compound is a chemical compound formed by atoms of only two elements. Why do we need a system to name compounds? Because they should refer to a single substance. The main function of nomenclature is that no chemical compound stays alive. What are the two types of chemical bonds? Ionic and covalent bonds.
Thank you, Diego, for that great introduction on basic things about compounds. So, now I'm going to be talking to you about ionic and covalent compounds. Well, both of these type of compounds include electrons. However, ionic compounds consist of transferring electrons from one atom to the other, which one of them loses an electron, which is normally the metal, and one of them gains the electron, which is the non-metal. So the metal is transformed into the cation and the non-metal is transformed to the anion. Covalent compounds are different from ionic because instead of transferring electrons, they share an electron. So now that you know what are the two main types of compounds, ionic and covalent, we are now going to be talking about the three types of binary compounds. For the first type of binary compounds, we will be looking at a metal and a non-metal. The metal will be of the alkaline earth metals, and some of the boron family. If we are giving the formula for a type 1 binary compound, which in this case would be lithium, 2, and oxygen, we only have to look at the elements and write first the metal and then the non-metal. The non-metal, remember that we'll always need to include an "ide" ending. So if lithium goes first and oxygen goes second, we would do lithium oxide. And if we are giving the name first and we need to make the formula, we need to look at the names, which is lithium and oxide, and then we need to see at the charges for each. So in this case, lithium has a charge of 1 and oxygen has a charge of 2, so we need to add one more of lithium so that it would be the same as the 2 charge for oxygen. So we would need to write lithium 2 oxide. A real-life example for type 1 binary compounds is salt, which is sodium chloride. Can you guess what the formula will be? Well, if you guessed NaCl, you will be right. For example, let's say that we are giving this formula, copper and iodine. We know that copper is a transition metal, so it might have one of two charges, and we also know that iodide will always have a charge of 1. So in this case, we're having 2 iodides to complete for this copper atom, which means that the copper has a charge of 2. So when we're naming it, we need to specify that we're using the charge of 2 for copper, so then we need to write it as copper, the Roman numeral 2, iodide. And when we are giving the name for type 2, we need to do the same thing as we would for type 1. We look at the names, their charges, which is 2 and 1, and then just add one more of iodide so that it would be the same as the 2 for copper. So copper iodide. Type 3 compounds are similar to the other two that we discussed because they are all binary and they all include 2 elements. But they're different because they include 2 non-metals. No metal. It's only non-metal. So now let's say that we're trying to name a type 3 binary compound, which is in this case carbon and then oxygen. They are both non-metals. So when we name them, this is different from the other compounds because we need to use suffixes to specify how many of each atom we're using. And in this case, we can see that we're using 2 oxygens, so it would be di, which means 2 dioxide. Carbon has only 1, so it's mono, but like it's the first element, we do not need to include mono. So for this case, it would be carbon dioxide, carbon, which is 1 carbon, and dioxide, which is 2 oxides. And if we're giving the name, which in this case is carbon dioxide, we just need to write the number of atoms that it specifies for each. For example, carbon, we know that it has 1, so it's just the C, and oxygen is 2 because it's dioxide, so carbon, 1 carbon dioxide. A real-life example for type 3 compounds is water, which has 2 hydrogens, dihydrogen monoxide, 1 oxygen monoxide. Remember that you do not write mono for the first element. So this has been it for our part. You now know how to name and how to write the formula for each of the compounds. You know some real-life examples and some similarities and some differences between them. Thank you.